Most gardeners try to, add life to their soil by buying it in a bottle. Liquid microbes, worm castings shipped across the country, expensive inoculants with impressive labels. Folks really go all out. Meanwhile, their soil still lacks earthworms, their compost breaks down slowly, and their beds compact by mid-season. The mistake is chasing inputs instead of triggering biological activity with simple carbon sources that microbes and worms actually respond to. The rice trick I'm about to explain is honestly one of the simplest and most effective biological triggers I've tested in raised beds, in-ground gardens, and even adapted systems connected to hydroponic runoff management. It costs almost nothing, but when done correctly, it increases microbial bloom, attracts worms, and improves soil structure naturally. If you care about soil that gets better every season instead of needing constant correction, go ahead and subscribe to the Farm Logic channel now. This is the kind of foundational practice that serious growers use quietly year after year. The real issue is that most soils are biologically underfed. Even gardens that receive compost annually can stall biologically. Organic matter might be present, but microbial activity fluctuates. Worm populations lag behind. In heavy rain seasons, nutrients leach faster than microbes can stabilize them. In dry climates, biology slows dramatically. Cooked rice, used strategically, acts as a rapid microbial substrate. Plain white rice, specifically from Oryza sativa, is primarily starch. Starch is a dense carbohydrate. When introduced into moist soil in small, controlled amounts, it becomes a fast energy source for bacteria and fungi. That microbial bloom then feeds larger organisms, including earthworms. Now, this is not about burying bowls of leftover rice randomly. Done poorly, that attracts rodents and creates anaerobic pockets. But, done correctly, it jumpstarts soil food webs. Here's exactly how I apply it in a standard 4x8 raised bed. I cook 1 cup of plain white rice without salt or oil. Once cooled, I break it up so the grains are separated. Then I mix that 1 cup of cooked rice with about 2 to 3 gallons of finished compost. The compost acts as a buffer and inoculant. You're not putting raw starch directly into the soil. You're preloading it with microbes. In early spring, when soil temperatures are consistently above 15 degrees Celsius, I spread that compost rice blend in a thin band about 2 inches wide along the planting rows or around transplants. Then I lightly scratch it into the top inch of soil and water it in thoroughly. Within 3 to 5 days, microbial respiration increases noticeably. You can actually measure this with a soil thermometer and moisture meter. The soil warms slightly faster in treated zones due to microbial activity. Within 2 weeks, worm activity increases in those areas. When I dig gently near treated bands, worm casts become more visible. Now let's be clear about scale. For a 32 square foot raised bed, 1 cup of cooked rice per month during the active growing season is more than enough. Overdoing it can create temporary nitrogen competition. Microbes need nitrogen to process carbon-rich starch. If your soil is already low in nitrogen, adding too much rice without compost support can cause short-term yellowing. That's why I always pair rice with compost or vermicompost. The compost provides both microbes and balanced nutrients, and the rice provides energy. In heavier clay soil, this method is especially useful. Clay tends to compact, reducing oxygen. Microbial activity helps aggregate clay particles into stable crumbs. Over 2 growing seasons, I've seen compacted clay beds become noticeably easier to work after consistent small-dose rice amendments combined with mulch. Sandy soil responds differently. There, the benefit is less about aggregation and more about microbial stabilization. In sandy beds, I bury the rice compost blend slightly deeper, about 2 inches down, to prevent rapid drying. Worms are drawn to the moist organic pocket, and their tunneling improves water retention. Now let's address the microbial angle more deeply. When starch enters the soil, bacteria capable of producing amylase enzymes begin breaking it down into sugars. Those sugars fuel rapid bacterial reproduction. Fungal networks also benefit indirectly as bacterial biomass increases. This bacterial bloom creates a short pulse of activity that stimulates the broader soil food web. In my own comparisons, beds treated monthly with small rice compost applications showed higher visible worm counts than untreated beds receiving the same compost volume without rice. I counted an average of 30% more earthworms in test quadrants after 3 months. Worms are not just indicators of health. Their castings increase nutrient availability and improve soil structure. In tomato beds treated with this method, I observed thicker root systems and slightly improved fruit set consistency during heat waves. Hydroponic growers might think this doesn't apply. Direct rice application into hydro systems is not appropriate. However, if you're running a hybrid system where runoff drains into soil-based beds, stimulating microbial zones around drainage areas with rice compost blends improves nutrient capture. I've used this around the perimeter of cocoa-based drip systems that drain into living soil trenches. The microbial activation reduced nutrient runoff smell and improved overall soil vitality. One common mistake is fermenting rice improperly and creating anaerobic sludge. Some growers attempt to soak rice in water and pour the cloudy liquid directly into beds. That can work in small doses, but it's unstable and often smells sour. I prefer solid cooked rice mixed with compost because it provides structure and prevents oxygen deprivation. Another correction, this is not a fertilizer replacement. Rice does not supply meaningful NPK levels. Its value is biological stimulation. If your soil lacks organic matter entirely, you must build that foundation first with compost and mulch. Rice is a catalyst, not a base. Timing matters too. I apply rice during active growing periods when soil temperatures support microbial life. In cold winter soil, the effect is minimal. In peak summer heat, I reduce frequency to avoid excessive microbial oxygen demand in already stressed soils. Let's talk about pests. If you bury rice shallowly and cover it properly with compost and soil, rodents are rarely an issue. Leaving exposed clumps on the surface invites problems. I always ensure the blend is integrated into soil and watered in immediately. Over a full season, the cumulative effect becomes visible. Soil texture improves, surface crusting decreases, mulch breaks down more evenly, worm casts appear regularly after irrigation. Crops show fewer signs of micronutrient deficiency because active biology improves nutrient cycling. This method is inexpensive and scalable. In a small backyard garden with 4 raised beds using 1 cup of rice per bed, monthly costs almost nothing. In larger systems, you scale proportionally but maintain restraint. Excess starch can create imbalances. The bigger lesson here is understanding soil as an energy system. Microbes need carbon energy sources. Compost provides slow-release carbon. Rice provides quick-release starch. When used together in moderation, they create pulses of biological activity that cascade upward through the soil food web. I've tested bottled microbial inoculants alongside this method. The rice compost approach consistently produced stronger visible worm response. That tells me the limiting factor wasn't microbe presence, it was available energy. If you want more worms, feed the microbes. If you want better soil, support the organisms already there instead of importing life in a package. Try it in 1 bed this season. Keep the rate controlled. Observe worm activity and soil texture over 2 months. Compare to a bed without rice supplementation. Serious growers measure results, not trends. If practical soil biology methods like this help you grow better food, subscribe to the Farm Logic YouTube channel and share this video with another gardener who wants living soil, not just fertilized dirt. The more we understand how to activate the systems beneath our plants, the more productive and resilient our gardens become year after year.